Right, so welcome to 3.12, continuing our writing and solving of rational equations and inequalities. Want to remind you that we are now going to be posting a comment which can be either a question that you have, or you can reply to someone's question with an answer. You could do both if you want, but you do need to do at least one. And the way that I'm going to keep track is that before you write your question or your answer, I want you to tag yourself. So you're going to put your first name followed by a period, then your last initial, and then your period. Period, and then your period number. So to give you an example, if my name is Tamir and I am in second period, then I'm going to tag my comment as follows. Alright, and that way I can tell who it is and I can give you credit for it. Alright, so make sure that you make that happen. I am going to ask you for today, you can have your question be on either, question or answer, be on either one of the questions that we talk about, but it needs to be specific. So it can't just be like, how do I answer this question? It needs to be something that an issue that you've come upon during your solution, or something that's specific and not really general. Alright, let's go ahead and move. So I want to come back to this question of Tim and Jacob working together to paint a fence. And we went over it in class a little bit, but these can be kind of tricky. And so what I want you to do is, not looking back at your work, I want you to give this another shot. And make sure that you go through it all the way, think it through, come up with what you're trying to find and a plan for how you're going to get there. And all I'm going to do is just quickly discuss sort of the basic setup, so that if that was something you struggled with, you can move on. And then I'm also going to give you the answer so that you can check your answer, but you should be going back and working through it yourself. So give that a try, and then we'll talk in about 5 seconds. Alright, so the tricky part of this question is really understanding what it is that I am trying to find. And you might be tricked into thinking that I'm going to be solving for some variable t right off the bat, because I'm asked how long it will take Jacob to paint a whole fence on his own. And we know that if I can figure out the rate at which Jacob will paint, the rate at which he's painting, that we could then use that to figure out how long it will take him to paint one whole fence. And so what we're going to look for is, we're going to look for the rate at which Jacob is painting. And the reason we want to look at the rate for which he's painting is because when we think about the big picture, when we look at the type of equation that we're going to write, we want to remember that the relationship we know is that the work that one person does, so we'll think about Tim, the work that Tim does, plus the work that Jacob does, that's going to add up to the total amount of work that they accomplish together. And so when I consider this situation here, I know the work that they accomplish together, it ends up being one whole fence. And then I can compute, you can think about, how would I find the work that Tim accomplishes? Well, I know his rate. He paints one fence every 5 hours, so he paints 1/5 of a fence per hour. That's his rate, right? Because this will be the rate at which he works times the time for which he works. And the time that he works for is going to be 2 hours, right? They work together for 2 hours, so it'll be 1/5 times 2. And then the same thing is true for Jacob, right? The work that he accomplishes is the rate at which he's working times the time. And that's what I'm looking for, right? I want to see the rate. I want to find the rate at which he's working. So that's going to be my variable, r sub j, and I'm going to multiply that by the amount of time that he works, which is 2. Okay, eventually when I'm all said and done, I find that the time it takes for Jacob to paint one whole fence on his own is going to be 3 1/3 hours. Okay, so go through, work it out. It might take you a couple of tries, but you'll eventually get there, and see if you can't come up with maybe a question or two that we can answer tomorrow in order to get us feeling really comfortable about this process. So to get us prepared for this last type of equation that we're going to discuss, I want you to answer this question. So what is the relationship between the concentration of a mixture, C, the amount of pure content, P, and the total amount of mixture, T? So think about it, maybe come up with a little bit of an example for yourself. I know we've talked about juice in the past or a chemical composition. But try and write a relationship. If you can, try and write it in words and as a mathematical equation, and then we'll talk about it briefly. So when I think about the concentration of something, right, the concentration, for example, let's think about lemonade. The concentration of lemon juice would be how much of your lemonade, what percentage of your lemonade is pure lemon juice. So the concentration is, in other words, just the percentage of something in a total mixture. So to compute the concentration of something, I want to know how much of my pure content do I have in relation to the total amount. So I'm going to take the amount of pure content and divide it by the total amount. So concentration is just going to be the amount of that something that you have divided by the total amount of the mixture in your bowl or whatever it is that you're using. Okay, so to give us just a really brief example, let's say that I have 10 liters of lemonade, and in those 10 liters I have 2 liters of pure lemon juice. So my concentration in this case, I have 2 liters of the pure lemon juice, 10 liters total, so my concentration is going to be 0.2 or 20% concentration. All right, with this in our back pocket, now let's go ahead and apply this in solving some more complicated situations. A company wants to increase the 10% content of its product by adding pure peroxide, which is 100% peroxide. The pure peroxide will be added to 500 liters of the 10% solution. So first question is, how many liters of pure peroxide should be added to produce a new product that is 28% peroxide? And then B, is it possible to mix enough pure peroxide with 500 liters of 10% solution to create a 100% concentrated solution? Explain your answer. So at this point, you're going to go ahead and split your paper up. Make sure you've written down both questions. You can either split it up horizontally or vertically and give it a try on your own, right? Just come up with, look for what you're trying to find, come up with a plan, execute it to the best of your ability, and then we'll go ahead and pause and we'll talk a little bit about it and hopefully get you on the right track. All right, so when I'm taking a look at this situation here, there's some key pieces of information that are going to help me get there. So I know that I want to increase a 10% concentrated solution. Okay, so if I just think about that in general, that means 10% of my solution is this pure content. And I'm going to do that by adding the pure peroxide. Okay, so in order to do that, I'm just going to dump in some more pure peroxide. The pure peroxide will be added to 500 liters of the 10% solution. All right, so when I take a look at question A, I'm going to need to sort of figure out, well, what am I going to need to do to make my concentration 28%? And here the method that is going to help us get there is to create an equation which will model this situation. Okay, so which can model the concentration of our liquid. So what we want to remember is that the concentration of our liquid, C, is going to be equal to the pure amount of pure content, I'll just use pure, divided by the total amount. Okay, and so now that we have this basic idea, it's going to be a lot easier for us to create our equation. So we know that we're solving for C. C is our concentration. Now, what's the amount of pure peroxide. And so here we've got to do a little bit of work. And it's helpful to sort of think about where I'm starting at. Remember, that was one of our tips. Consider where you're at right at the beginning. Take some simple cases. You know that you have 500 liters of this solution to begin with. So let's just work over here. I know that at the beginning, my total is 500 liters. Okay? And I also know that the concentration is 10%. Right? So my concentration is going to be 10% or 0.1. So how much at the beginning, what is my amount of pure content? Well, at the beginning, I have 10% out of 500. So I could solve here for what the pure content is by isolating P, or multiplying by 500. In other words, taking 10% of 500. So I'll go ahead and do that. I'll multiply by 500 on both sides. And then all of a sudden, I'm left with the pure value, which is simply going to be 50 liters, right? And that makes sense. If P were equivalent to 50, well, 50 out of 500 is 0.1 or 10%. So at the very beginning, my situation is that I have 50 liters of pure peroxide and 500 liters of the total content. But I'm not going to keep it like this, right? I'm going to be adding some pure amount of peroxide. And so this amount that I'm adding here is what I'm trying to solve for, and we're going to call that X. Okay? So the pure content that I have is going to be the 50 that I started with, plus the amount I'm adding. The total amount that I have is going to be the 500 that I started with, plus any amount that I add. And to help us see this, imagine you just wanted to add 1 liter of pure peroxide. So if you wanted to add just 1 liter of pure peroxide, you would have 50 that you started with plus 1, and your total amount of liquid is the 500 that you started with plus the 1 liter you just added. So notice that the amount you're adding has to be incorporated into the numerator and denominator, into the pure content and the total. So now we have this equation, and now you're set. So this equation here is what's going to lead us to be able to solve for a concentration of 28%. Right? So now my remaining part of my plan should be use the information, right, this 28%, to solve my equation for X. So I'm actually going to give myself plenty of space, I'm going to move down here, and I'm going to plug in 0.28 for my concentration, and I'm going to solve. So what I'm going to let you do at this point is finish out this problem and solve it. Okay? I don't want you to give up easily. All right? You should spend at least 5 to 10 minutes going through this, and this should not be the last thing that I see on your paper. You are going to go through and find the X value that we're looking for. Okay? And if you need to look back at notes or some previous techniques, do so. Then I want you to answer question B. That should be the last thing that you do. And for question B, right, I want you to incorporate this in your comment. So your comment should say, you should have your question, and then you should put a section that says Part B, and is it possible, yes or no? Okay, I just want to take a quick tab. Is it possible, yes or no? And if you want to include an explanation, that's perfectly fine. Okay, so go ahead and give that a shot, and I'll see you tomorrow.